Yes, welcome my dear students and the real GATE aspirants. Welcome to this live session on memory based explanation to the solutions for GATE Electrical Engineering 2025. Here myself B.S. Krishnavarma with the team of most experienced faculty in India. I would like you to go with this series of presentation, and once we get the most accurate question paper, we will also publish them. Be ready for that, but based on the student feedback and the memory what we get, we are giving you the best possible and accurate solutions. And I welcome all my experienced faculty members to this live presentation. Yes, as I told, this is purely based on the memory based questions given by our favorite students, and lot of students still are emailing us and sending through WhatsApp. So whatever best we can, we will support. Now, yes, this is a solution to the question paper for Electrical Engineering GATE 25. Now, as per the latest data, just 20 minutes back, these are the division of number of questions for each subject. Like electric circuits 4 came, they are saying 5 also, but electromagnetic fields 3, signal 6, machine 6, power system 6, control system 7, electrical electronic measurements 2, digital electronics 2, analog electronics, power electronics 4, mathematics 7, and aptitude 10. So I think still there is a way that it is still evenly divided, but maybe 1 or 2 bits here and there, we are still waiting for the accurate feedback. Now, as per the data available, yes, numerical analysis type questions 26, MCQ 35, and MSQ 5 questions came. Now, I will be talking about electric circuits for electrical engineer. Now, this is one of the question came. Clearly, it shows it is AC supply. So, it is a steady state AC signal, RMS 200 volts. And here also RMS 9 volts and RMS 199 volts across this RL load, and is asking the power drawn. You remember this question came in 2012 GATE. There the difference is he did not give this resistance, he gave the voltages, but he gave the load resistance value. But with respect to that, here he also gave resistance, so we can directly find the current. Now interesting is it is a phasor problem. Don't misunderstand, it is a DC. Symbol shows sinusoidal AC, RMS values, and phasor diagram will solve it. Now here if you really solve, now this is RL load. Now because it is a series circuit, I will take current as reference. With respect to current, which voltage will be in phase? Voltage across the resistor, that is 9 volts. Okay. Which voltage? This is RL load. In RL load, current lags voltage by angle less than 90, or with respect to current, voltage will lead by less than 90. Voltage will lead, and how much it is? 199. Very high value. Of course, this is 199 volts because RL. And he gave the phasor sum of this voltage and this voltage is supply voltage, which is 200. But this is not right angle triangle, please. So yes, if you do use the parallelogram law of vectors, the phasor sum of this is total 200. Now he is asking load power factor or load power actually. Now load power is simply load voltage, load current into power factor of the load. Okay. Now see, the angle between load voltage and load current is the power factor of the load. Now load voltage is this, load current is this. This angle is the power factor angle of the load. But you know this is not right angle triangle. So we know the resultant of two vectors. Resultant, that is how much? 200 is equal to root of R1 square 9 square plus R2 square 199 square plus 2 R1 R2 cos of angle between them itself is the load power factor. If you calculate, yes, if you do calculate, you will get this cos phi L. See, as per the data, it is showing very low. Okay, 0.088 is the value I got. Okay, may not be so accurate, but the data given by a lot of students, yes. And once you got this, now what about the load current? Now this load current itself is the current because it is a series circuit. This RMS voltage by resistor itself is a load current. So if you see here, load voltage RMS is 199, load current RMS is that 9 by 2, 4.5, and power factor is 0.088. And if you do that, you are getting an answer around 78.8 watts. Okay. But still, this is based on the numerical value given by the students. Okay, that is it. But this was similar to 2012 gate question. Now this is an interesting question. He is asking the VI characteristics. Okay, VI. Where is the voltage here? This voltage only. Okay, VI characteristics. Now what you do with such problem? You just test it. Okay, like you test by taking some random load, resistor, and vary it. Now with the data available, yes, with the data available, what I did is, see, this is 1 ampere and 1 kilo. Now when voltage is 0, it means open circuit. When voltage is 0, open circuit, this current only will flow here. Na? So 1 ampere into 1 kilo. Okay, 1 ampere into 1 kilo, that will be the. So when voltage, see, when this is open circuit, yes, that is what I saw. So this I is going to be 1 ampere. Okay, when V is 0, yes, short it. V is 0, short it. And this current will flow because this becomes redundant. When V is 0, short it, this becomes redundant. Okay, then I is 1 ampere because this passive element parallel to short circuit is redundant. So this is the answer. So that means when V is 0, I is 1. Okay, V is 0, I is 1. All these are possible answers except this. Okay, all these are possible answers. But what about when you increase or decrease the load? Now what I will do is I will put some load resistance and vary. Now randomly what I took is to the same network. Now I added another 1 kilo ohm. See what I did? This is already 1 ampere. And this is 1 kilo. Now I took another 1 kilo here. Now the moment I took 1 kilo, this 1 ampere will divide into 2 equal halves. This is half ampere. When half ampere is going through 1 kilo, this is how much? 500 volts. That means for 500 volts, yes, current here became how much? Half. So current has decreased. As voltage has increased, current has decreased. Initially what I took? Short. When it is short, voltage is 0, current is 1. But as I connected an external resistance to this system, current is dividing into 2 equal as this is 1 kilo, but voltage is 5. Now further, suppose I increase resistance further. Now to the same system or same network, if I further increase the resistance like 1 kilo and this is 2 kilo and this is still 1 ampere. Now this will be clearly how much? 1 by 3. Yes or no? Now 2 kilo by 1 by 3, voltage will be how much? Yes, 2000 by 3, somewhere around 666 volts. So you see, as the voltage drop is increasing, short circuit 0 voltage, 1 kilo ohm 500 voltage, 2 kilo ohm 666 voltage. As the voltage drop increasing, current in that is decreasing. As a voltage drop, that is the property of practical current source. As a voltage drop increasing, current is decreasing. Okay, we call it as regulation, right? So this is the option. Okay, only in ideal current source, you know, current is always constant. This cannot be the case. How can current increase? Yes. So only in ideal current source we learn this, but here clearly it is a practical current source with internal resistance. So current regulation, as load is increasing, yes, voltage drop, yes, clearly current is decreasing. So just take some random value and check it. In exam, don't panic, just take some random values and check externally to the terminal voltage and terminal current. Now this is one of the most accurate data I got. Yes, I believe this is the most accurate data. See this question here. At what time okay, t seconds, the voltage will reach here 50 volts is asking. So voltage across capacitor reach 50 volts at what time? At what time? But it is a transient where switch is closing at t equal to 0. So from that time we have to calculate the instant when switch is closing, at what time this reaches 50 volts. Now sir, this is clearly step response first order. Yes, step response first order RC circuits, and state variable is voltage across capacitor. We know this. V of infinity plus V of 0 minus V of infinity e power minus t by tau. Now V of 0, if you observe V of 0, what is V of 0? See, switch was open, this current will flow here, 325, so this is 75 will come, and this is 100. So automatically this will be 25, yes or no? So this V of 0 is clearly 25, yes or no? Because the switch was open, here 75, here 100, current is not flowing as capacitor is open circuit previous state. So this is clearly 25. Then what about this V of infinity? Yes, if you go to V of infinity, now after closing switch, see, after closing switch, directly see, after closing switch, that is an independent part, this 100 volts will appear here. So V of infinity is 100 volts. Yes or no? Yes, V of infinity 100. Then what about time constant after change? Now after change, switch has closed, this is an independent circuit, tau is RC, okay, after switch has closed, this circuit only will interact with capacitor, so tau is RC, which is 10 seconds, tau is RC, which is how much? 2 into 5, 10 seconds. So now if you observe, yes, if you observe the data, this V of t is V of infinity, okay, yes, V of infinity plus V of 0 minus V of infinity e power minus t by tau. But he is asking at what time this reaches 50 volts, right? He is asking at what time this voltage across capacitor reaches 50 volts. So let us substitute 50 here. So if you substitute 50 is equal to 100 plus, is 100 minus 75 e power minus t by 10. Okay, if you observe, yes, if you solve it, yes, natural logarithm you see here, 75 e power minus t by 10, okay, and this is going to be 50. So e power minus t by 10 is 2 by 3. So natural logarithm minus t by 10 is natural logarithm of 2 by 3. If you do that, this value came, yes, use calculator, virtual calculator, minus 0.40546 it came. So minus minus cancel, t is 10 times of this, so 4 seconds approximate, okay. Yes, I think it is a numerical type question, it is 4 seconds, okay. Then one more power factor question came. Now this is a latest edition which I could not make slide. Just few minutes back it came. Here voltage function is given as 300 sine omega t, and current function is given as 10 sine omega t minus pi by 6 plus 2 sine 3 omega t plus pi by 6 plus sine 5 omega t plus pi by 2, and is asking total input power factor. Total input power factor. Now you know there are 3 cases. I told when it is power calculation, I categorize any system into 3 cases: sinusoidal supply to linear load, non-sinusoidal supply to linear load, and sinusoidal supply to non-linear load. Which case it is now? Supply is pure sinusoid, means no harmonics, pure sinusoid. Okay, for pure sinusoid there is no harmonics. Fundamental itself is the function itself. But current is given as fundamental, third harmonic, fifth harmonic, means it is non-sinusoidal. Giving sinusoidal voltage and getting non-sinusoidal means it is non-linear load. This can happen only with the non-linear load, like for example power electronics or analog electronics. Now there is asking total power factor. Now here to find total power factor or input power factor, it is distortion factor into fundamental power factor. That is very important. What is fundamental power factor? Fundamental power factor is cos of angle between fundamental voltage and fundamental current. See omega t. That is cos of this. That is cos of 30 pi by 6 na, that is 0.866 you will get. And distortion factor is how much? I1 RMS by I total RMS. What is I1 RMS? 10 by root 2. But what is I total RMS including harmonics? Root of 10 by root 2 square plus this is 2 by root 2 square and plus this is 1 by root 2 square. See, as per the data I am writing here. And if you do that, yes, one way you will get this as 0.866 and you will get this as 0.97, okay. And now total power factor is these two product you take, you will get it as 0.8449. I got accurately, and option was calculating luckily, okay, option was matching to one of the student data, okay. And there is one problem on magnetic circuit, but the data is not accurate. It is like a derivative type where he is asking the minimum stored energy for a coupled coils for what ratio of current he asked. The data is not accurate, sir. Once it is accurate, we will present to you. Okay. So yes, this is what I could say. Some 4 to 5 questions came in networks. Okay. Now I would request measurement sir to take over, and please go through every teacher here. They are all ready, and as most accurate paper comes in few more days, we will publish that. But yes, as per the memory, we are giving you the best possible solutions. Okay. Thank you. అట్లా ఎవరు ఇచ్చింది మళ్ళీ స్టార్ట్ రైట్ నౌ the question is from error analysis, right? Here R total they are asking, R total formula is R1 R2 by R1 plus R2, and addition operation is there, therefore we need to have value form of errors 100 plus or minus 5, and if you convert this 900 plus or minus 45. And if you substitute, multiplication operation is there, so substitute percentage errors 100 plus or minus 5%, 900 plus or minus 5% divided by 100 plus or minus 5 plus 900 plus or minus 45. And if you simplify this, finally you will be getting the answer like here 90,000, right, plus or minus, this is 10%, and divided by 100 plus 9,000 plus or minus, but here we need to calculate this as okay 50, and then division operation is there, percentage form of error we require, therefore 90,000 plus or minus 10% divided by 1000 plus or minus, what is a 50 out of 1000 is 5%, so this simply, if you simplify this, 90 plus or minus 5% is the answer. We have to subtract the errors, therefore 10 minus 5%. This is one question. Next question is from bridges. It might be 2 marks question. Right, here he is asking like, what is the sensitivity? He is asking sensitivity of the bridge. The sensitivity formula is delta V by delta R, delta V by delta R simply. So we need to find out delta V. Delta V is equal to V02 minus V01. But if you see the bridge, 1K into 50 and 10 into 5K, initially the bridge is balanced. So therefore, V01 is equal to 0 because, right, initially balanced.
initially balanced. We need to find out V02. How do you find out V02? Apply the corresponding voltage division law. 10 into we can write the voltage division law like 5000 by 5000 plus 51 minus 1000 by 1010, right? And if you simplify this, we are going to get the value as 1.96 millivolt. Sir, V02 is 1.96, V02 is 1.96, V01 is 0. If you substitute here 1.96 minus 0, change in resistance we have taken here 1 ohm. So therefore 1, therefore we are getting 1.96 millivolt per ohm. This is the answer. These are the questions from measurement subject.
Let us see the signals and system questions. Total we got 6 questions this year. Most of the questions from introduction and LTI system convolution topic. One question came from Fourier transform. Let us see. Very easy model. A continuous signal, continuous time periodic signal is given by some expression. He is expecting the power in the periodic signal. 1 by t integral mod xt whole square dt. Generally for a constant, what is the standard power we have? A square. If it is a sinusoid, a cos or a sine, we are going to write a square by 2. Use that relation, we are in a position to know the power. So the power equals to 1, 1 means 1 square. For the second sinusoid given 2 square by 2, here also 2 square by 2, last one 2 square by 2. That comes under around 7 watts. Okay, very easy model. Directly power is asked, power in the periodic signal. This is one more question, standard property of impulse. X of t is given like this, minus t square into this. What does that bracket term indicates? U of t plus 4 minus u of t minus 4 means that signal is covered for the interval minus 4 to 4. This is clear indication of sampling or shifting property of impulse. What is that? Generally, integral yt into del of t minus t naught dt. If the shift is within the limits, we are saying the result is y of t naught. So now the impulse exists at minus 3. X of t is extra multiplied by impulse at minus 3, which is including the limits. So directly in the signal, substitute that instant. Directly in the signal, t naught is minus 3 here. Directly in the signal, substitute that instant. So result will be minus 9, which is based on the sampling or shifting property. Okay. This is the next model that is asked. Continuous time unit impulse signal is applied as input to a continuous time invariant system. Output is observed to be u of t. You have given del t as input. We got the output as ut. So possibility of integration, you can feel system as integrator. So which of the given statement is true? What is the first statement given? Every bounded input signal applied to that system results a bounded output signal. When you try to apply input with some finite amplitude, he is saying that system will produce bounded output. Need not be true. Why? Suppose we are trying to apply a bounded input like step function ut, we are producing the output as ramp, integration of step. Ramp is unbounded. It is possible to find, let us see the second option. It is possible to find a bounded input signal which when applied to S results in unbounded output signal. Based on the other two options, let us make a conclusion on option B. Based on other two. What is the third option given? On applying any input signal, it need not be bounded. On applying any input signal to the respective system, what is the system here? Integrator. The output signal is always unbounded. That is also meaningless. Because suppose I want to apply a small rectangular pulse, ut minus u of t minus 1. If I am integrating, I am getting output as r of t minus 1, which is of course bounded. It is maintaining finite amplitude. So option C is also failure. What is option D? On applying any input signal to that system, output signal is always bounded. That is also meaningless. Again, it is same as option A. If I am applying ut, I am getting ramp, that is unbounded. Option A, I have given input as ut, I am getting output as ramp. That means output is unbounded, but he is saying output is always bounded. So that is also failure. So the best possible option is what? Option B. That is the best possible. So rest of the questions will be dealt by Mr. Aditya.
So now look at this problem. This pattern has already appeared. They gave x1 and x2 and they are saying y of t is x1 convolved with x2. They are asking what is integral minus infinity to infinity y of t dt. It is the area property under convolution. So if you want area or integral value of y of t like this, find area under x1 and find area under x2, just multiply them. So try to draw what is x1. What is x1? So from 0 to 1 it's a constant. And from 1 to 2, it is 2 minus t. So let's mark this as 1, let's mark this as 2. So at 2, 2 minus 2 is 0. So the remaining, it's like a ramp. So this height is 1. This is x1. Area under x1 I want. It's a very simple graph, area under x1. So you can treat this portion as a rectangle. So 1 into 1. The other portion as a triangle, half base into height. So half base is 1. Height is also 1. So 1 plus 1 by 2 is 3 by 2, which is 1.5. Also find what is x2 and then find area under that. So x2 is also a simple waveform. So let's mark these values 0, 1, 2. So from 0 to 1, it's a ramp like this. And from 1 to 2, it is 2 minus t. So I think most of you are comfortable in drawing this. The height of this is 1. This is x2. What is a2? Half, this is like a triangle, half base into height. So half base is 2, height is 1. So this area is 1. Now this is 1 and this is 1.5. According to the convolution property, you have to multiply the individual areas. So 1 into 1.5 is 1.5. 1.5 is the answer for this question. Now this is central ordinate property. According to central ordinate, h of 0 is 1 by 2 pi integral minus infinity to infinity h of j omega d omega. So 1 by 2 pi. So it is only from minus 200 pi to 200 pi. So and in this range of frequencies its value is 1. So it's a simple question. So this will be like 400 pi by 2 pi, which will give you 200. Now let's look at this question. Consider an LTI system S, and y of n equal to s of x of n is like some transformation on x of n producing the output y of n, where x of n is the input and y of n is the output. Now they are also describing the impulse response. So s of del of n means like if I apply del of n, what kind of output I get. So it's like the impulse response is 1. The impulse response is 1 whenever n is 0, 1 and 2. So it can be written like this, h of n. So it can be written as del of n plus del of n minus 1 plus del of n minus 2. It's a LTI system. You know the impulse response, and x of n is the input. How do you find the output? It is a very simple expression. Y of n is x of n convolved with the impulse response. So when x of n convolves with this, this and this, so we repeat in the class, when x of n is convolved with impulse, again you get x of n. So this is x of n plus, when x of n convolves with this, you get x of n minus 1 plus, and then this is x of n minus 2. So what could be the answer? It is clearly option B. So that's it from signals and systems. So next, control systems faculty. So Nagesh Rao sir will take over the session.
In control system, they asked 7 questions. This is one question related to the time domain analysis. Here given a step response is given. Step response of first order system is given, and given a data instead of the response. So what is the response given here? Based on data, Okay. Okay. So based on the data, you can draw the step response. This is t, this is c of t. If you draw the step response, it is moving up to the steady state value of what? 3. The step response increased from 0 to 3. The steady state value is 3. So write the output for this. What is the equation for this? Tell c of t equal to, so if you write it, c of infinity plus c naught minus c of infinity e power minus t by tau. So what is c of infinity? 3. What is c naught? 0. You substitute this. So you will get the output equation is c of t equal to 3 into 1 minus e power minus t by tau. So this is the output equation. So what they are asking, we have to find the what? Time constant you have to find. You have to find the time constant of the system you have to find. So you can use the data output, and at that output what is the time you can use, and you can find the time constant. Anything, either 0.6, 0.78 or 1.6 at 1.65, anything we can substitute, we can get the time constant. For example, I will take this. So output is 0.78. So output is 0.78 equal to 3 into 1 minus e power at what time? 0.78. At what time? Time is 0.6. So 0.6 divided by tau. You solve this, you get the tau value. You will get the approximately 2 seconds you will get. You solve this equation, you will get the what? 2 seconds. That means the answer is what? A. Next, second question. So here you given a g of s and closed loop system is given. Is asking the what? Is asking the range of k for stability. So then you write the here g of s. G of s, if I write this block, I consider as gc of s, for example, gc of s equal to what I can write? K into s minus 1 into g of s divided by what? S plus 1 into s plus 2. You write the characteristic equation. What is the characteristic equation? 1 plus, for example, gc of s equal to 0. So if we expand this, what you are getting? S square plus, here expand 3s plus 2 plus ks minus k equal to 0. So here I can write this characteristic equation, s square plus s terms, if you take it common, so s term take it common, k plus 3, k plus 3, and constant terms you take it common. What is the constant term? 2 minus k. So plus 2 minus k equal to 0. According to necessary condition, k plus 3 must be greater than 0 and 2 minus k must be greater than 0. That means k greater than minus 3 and k less than 2. So if you observe the options, and what is the range of k for stability? K greater than minus 3 less than 2. You observe the option, stable for all the values of k greater than 1 is wrong. Unstable, this is also wrong. So unstable for all the values of what? K greater than 2 is correct. So option D also wrong. C is correct. Next, so a controller D of S is given, and a PD controller, this is called the PD controller. So what is the PD controller transfer function? Gc of S equal to 1 plus KD S is given, and a given a system is 1000 into root 2 divided by S into S plus 10 whole square shown in figure. So here required phase margin 45 degrees at the gain crossover frequency of 10. So use the simply phase margin concept, you will get the answer. So what is the answer here? G of S with compensator if I take it. So what you are getting, tell? So 1000 root 2 into 1 plus KD S divided by, so S into S plus 10 whole square. Now write the phase margin. So phase margin equal to 180 plus angle of G of S with compensator we have to take it. At where? Omega GC. What is omega GC?
10 radians per second given. So phase margin how much I required? 45 degrees is required. So 180 plus what is angle GH? You write the angle GH. For this you write it. For if I write for pole minus 90, for pole is minus 90, and for PD controller plus tan inverse of S replaced by j omega, you will get omega kd by 1, and here 2 poles at where? 2 poles at 10. That means what I will get? Minus 2 times of tan inverse of omega by 10. So at where omega equal to omega gc equal to 10. So then 45 degrees equal to 180 minus 90 plus tan inverse of omega is 10. So 10 omega 10 kd so here omega 10, so 10 kd divided by 1 minus 2 tan inverse of 10 by 10 means it is what? 45, 90 degrees. This will become minus 90, here minus 90, this will be cancelled, then 45 degrees equal to tan inverse of 10 kd, 10 kd, tan 45 1 equal to 10 kd. So kd equal to 0.1. Answer is 0.1. Next, my colleague Gnaneswar will continue.
Yeah, dear students, control system question here from the root locus concept. A simple question here. Trans function is given. Just simple locate the pole 0 location here. Now, here I am indicating what is the zeros first. Examiner was given here. S at origin and plus 2. At origin is given. At origin 0 is given at S equal to 0, and at S equal to minus 2 also 0. And one check it trans function here. Minus 5, minus 7. Minus 5, minus 7 poles here. Minus 5, minus 7 are the poles. Now we know the odd number condition. This is the odd number here, observe. Number of poles and zeros are odd number, so it is on the root locus. It is not a root locus, not on the root locus. Not on root locus, it is on the root locus. It is on the root locus. It is not on the root locus. It is not on the root locus. So from the given option, observe here. So obviously minus 1 is on the root locus. Check it, minus 1 here. Minus 1 is on the root locus. Now next option, observe here. Minus 6 also on the root locus. Minus 6 also on the root locus here. So from this one, what is the best option here? Minus 6, B and D are the correct answer. From the root locus, simple question here. Now next coming to this question. Here examiner was given, observe, examiner was given close once in the anti-clockwise direction. So n is given is n minus 1 plus a0 point, critical point is given 1, and also given open loop system is stable. So all open loop poles are which side, come on tell me. Now which pole, all poles are in the left side. So number of open loop poles at the right side equal to 0. Obviously n equal to, p equal to 0. Number of open loop poles at the right side is 0. So here n not equal to p, obviously system is unstable here. System is unstable is correct answer. From the given option, select the
Unstable is the right answer. Next. Okay, very simple question. It is a CCF format, controllable format, controllable format. Now from this one directly we can write the characteristic equation equal to directly now minus s square highest power 2 cross 2 na matrix is 2 cross 2, so s square reverse mode plus 3s plus 2 characteristic equation. So we can write this one as a s plus 1 product of s plus 2. What are the poles? Tell me now. S equal to minus 1 minus 2, poles are minus 1 minus 2. So examiner is asking addition, sum means plus 3 minus 3, but here in the question paper magnitude here, magnitude means plus here. So what is the answer here? Answer equal to 3 is the correct answer here. 3 is the correct answer. These are the questions from the control system. Now one more question from the digital logic here, digital logic. Let us, in the question paper I have collected from the student here, what is the given data here? F equal to UV, generally ABCD, but here given U bar plus V bar, W bar plus X bar. SPOS format is given. Question paper is given SPOS format. Now one more term is given, U bar plus V complement plus W complement plus X here. Now one more term here, no space here, a multiplication. Now V complement, yes, fine. This is a U complement V plus W complement plus X complement. Now in the question paper, U complement plus V plus W bar plus X here. So we need to simplify by using K-map, no doubt. In the SSOP, it is a SPOS format. In the SPOS format, simple logic we know. Variable the variable here. Variable we need to indicate with a 0. Everyone knows. Now complements are indicated with 1 here. Complements are indicated 1 here. So indicated with 1 here. Complements are 1, 1, 1, 1. So indirectly this is a M15, max term of 15. Now here also 1, 1, 1, 0. This is a max term of 14. Now here observe 1, 0, 1, 1. Max term of 1010. This is a M15. This is a M11. Now here observe 1010 here. It is M10. So same question we can write. Same question we can write here. Now f of u v w x here. Correct na? The order here u v w x equal to max term of. Now from the given data 10 11 10 11 14 15. This is a given data here. 10, 11, 14, 15. Take the 4 variable K-map here. Simple, this is a 4 variable K-map here. 4 variable K-map. Now, 4 variable K-map here. Now, here examiner is given U, V, W, X here. Now, what are the 10 is given? 10 cells. Now, simple here. This cell's name I am writing here, cell's name here. This is a 0 cell 1, 2, 3, 4, 5, 6, 7. Now this is 8, 9, 10, 11. Now 12, 13, 14, 15 here. 14, 15. Now if we indicate the poles here, this one 0, 0, 0, 0 max terms. After max term here, group it here. If we group this one, we will get the answer F equal to U bar plus W bar here. U bar plus W bar. From the given option, observe options here. This R gate is given, R gate. From the given option here. Now here U, V. So this is a U complement, V complement plus R gate answer here, U complement plus V complement. This is the right option here. For this given data, now suitable option is U bar plus V bar. This is a question from the digital logic.
Okay. Let us look at analog electronics questions. A simple buffer amplifier is given. You can see the voltage at this node and this node both are same. Op amp tries to keep these two potentials same. So you have V in here and this has a gain 1 in the feedback. So now you can recognize the type of amplifier. This is a simple buffer. So option B is the answer. And moreover, you can see whenever you say summing amplifier, the word sum means there should be at least 2 inputs, but here only 1 input is there. So similarly, difference amplifier. How can you take difference? At least you should have 2 inputs, but here only 1 is there. So you can eliminate these two. Log amplifier, you need some nonlinear element like diode or something. So the leftover option is the right answer. Next, the true statement about small signal voltage gain of MOSFET based single stage amplifier are given. So you are asked to find which one is inverting and which one is non-inverting. Very simple question. We all know in a BJT and MOSFET, only common emitter amplifier will give 180 degrees phase shift. Common emitter or common source, this will give 180 degrees, so it is inverting. The other two configurations, common collector or common drain, common base or common gate, are non-inverting, meaning they don't give phase shift. Now we will see which option is correct. Common source amplifier is non-inverting and common gate amplifier is inverting. This is wrong. Common source is inverting, common gate is non-inverting. Common source and common gate, so you don't have to see this. Common source and common gate, whenever they say and, it means it is wrong. So common source is inverting and common gate is non-inverting. This is the right answer. Okay, so given an ideal op amp, what is the voltage gain of this problem? You are asked to find V naught here. V in, mind you, V in is the potential difference here. Suppose if I take Vx, this is Vy. The difference Vx minus Vy is actually V in. And what is op amp's job? Whenever you give negative feedback, it tries to keep these two potentials same. That is called virtual short. So if I take Vz and if I apply voltage division here, this is going to be Vz by 2 because two resistors of same value. So your Vy is Vz by 2, meaning Vy is Vz by 2. What do you mean by this? It means that Vz is 2 Vy. So this Vz is actually 2 Vy. Now let us find V naught to finish this problem. Here also you can apply KCL if you wish. So the current entering is equal to current leaving. Op amp tries to keep these two potentials same. So V naught minus Vx by 10k is Vx minus Vz. How much is Vz? 2 Vy. 2 Vy by 10k. So fortunately these two resistors are same. So we got the answer. V naught is 2 Vx minus 2 Vy. So what is V naught by Vx minus Vy? Vx minus Vy is V in. So your answer is 2. 2 is the right answer. So this is, or you can do it orally also. This is a non-inverting amplifier, 1 plus R2 by R1. So this is going to be 2, and you can also apply superposition theorem and directly get the answer. But I have solved it with KCL. Now go through the problem here. The M1 and M2 transistors are in saturation. Both transistors have some small signal resistance of RDS, transconductance GM. You are asked to find the small signal output impedance. So this is a standard circuit called the cascode amplifier. In a cascode amplifier, if you have some resistor R, directly the solution here, output resistance is going to be R0 plus 1 plus GM R0 or R01 plus GM1 R01 into R02. This is a standard formula. So R0 here is treated as RDS. So it is RDS plus RDS plus GM into RDS square. So it is going to be 2 RDS plus GM RDS square. So that is the solution. This is the standard solution, but if you want a proof for this, we can do the proof. So I need some space to do the proof. So you can see here, for this MOSFET, whenever you want to find the output resistance, the voltage has to be made 0. When you have voltage 0 here, GM VGS is also 0. So you are having only RDS. So this whole equivalent is only RDS, okay? So which is R here. So let me put RDS here, and the upper MOSFET is this. So this is a proof, not needed proof, because that is a standard cascode amplifier. So without proof you can do it. This is VGS. And how do you find output resistance? By Ohm's law, it is V by I. V by I. Here you are having GM VGS. So now you can see with one single KVL you can finish the problem. This RDS I am writing it here because it's the same node. So let us finish this problem by a single KVL. Minus V plus I minus GM VGS into RDS plus I into RDS equal to 0. Now if you apply the loop equation here, VGS is nothing but minus I into RDS, because VGS plus I into RDS is 0. Okay? So you substitute here, you will get V by I equal to 2 RDS plus GM RDS square. So this is a standard formula. I am just giving you a proof for this. Okay? So with this, these are the 4 questions I was given in analog. Seems to be a moderate paper.
Hello, good evening everyone. From overall machines we have the total questions are around 6 questions are there here. So let's see one by one. So this is our first question. This question related to synchronous motor. Given the voltage it is operating is 3.3 kV, 4-pole 3-phase synchronous motor has E equals to V. So magnitude of EMF equal to the supply voltage and are in phase at no load condition it is. This is at no load condition. Okay. If a mechanical load applied, it results a load angle of 2 degrees. So whenever mechanical load is connected under load condition, so there is a 2 degree angle here, load angle, and which shift the E phasor. Initially E equals to V at no load, both are in phase, but whenever load is connected, so this E phasor with respect to V phasor having a load angle of 2 degrees. Generally which one leads here? EMF lags the supply voltage by 2 degrees here, that is delta given. Then if XS is 2 ohms, then armature current in amperes is dash. So at load condition how much current motor will draw? Armature current. So simple question directly from equation of KVL, IA equals to V at an angle 0 minus E at an angle minus delta divided by XS at an angle 90 degrees because only XS is there, no resistance here. So the angle is 90 degrees. Substitute here. Given V is 3.3 kV voltage. So this is line voltage, and which is star connection, it is also there. Therefore, we have to take phase voltage here 3.3 kV divided by root 3 at an angle 0 minus 3.3 kV divided by root 3 at an angle minus 2 degrees divided by XS is given to at an angle 90 degrees. Now you may get doubt, how can we solve with the virtual calculator it is. So it is very simple. So you take here 3.3k by root 3 common, no? So take it outside first, 3300 by root 3 take outside. This is 1 at an angle 0 minus 1 at an angle minus 2 degrees. Then 3300 divided by root 3 outside I am taking, and this is 2 root 3 at an angle 90 degrees, and here we have remaining 1 at an angle 0 minus 1 at an angle minus 2 degrees it is. Then add these two. So what is magnitude equation of two phasors? Root of a minus b it is, a bar minus b bar. So root of a square plus b square minus 2ab cos angle between these two is 2 degrees here. So if you calculate like that also magnitude easily you will get. So you no need other form here. So simplify that. Finally the magnitude of current we are getting is 33.25 amperes. So this is the current magnitude it is. Okay. So as it is star connected, phasor line both are same here. Next question. The meters required to synchronize an alternator to the grid. So when we synchronize an alternator to bus bar, we have to check some conditions. So mainly we have to check voltage rating and phase sequence and frequency of two systems. So these three must be same here. So to check the voltage rating or voltage of two systems, we need a voltmeter there. So voltmeter required. And to verify frequency condition and phase sequence condition, we use a synchroscope. But if you see the options here, it is MSQ. So we have to choose more than one or two possibilities, whatever the possibilities are there from this question. So wattmeter we don't use here, and stroboscope we don't use, and synchroscope we use for frequency and phase sequence, and voltmeter also we use to check the voltage of two systems. So answer is C, D here. Next, this is from induction motor. The motor moves from initial operating point O. The motor moves from initial operating point O. This is. So there is a torque here and speed relation given. And this is the load torque variation in this load torque. Okay. Now see this. The motor moves from initial operating point O, which trajectory takes less time to reach that steady state. Or which path, trajectory nothing but path here. Which path motor will take in order to reach quickly that steady state operating point. Okay. So the answer here is, if you see OES given, first option. So you can eliminate that directly, because we know in order to accelerate the motor from 0 to steady state condition, the electromagnetic torque should be always greater than load torque. And finally motor rotating at one constant speed means what is the condition it has to achieve? The electromagnetic torque finally should be equals to load torque, so that motor will rotate constantly at one speed here. That's why electromagnetic torque should be greater than load torque in the accelerating period. So you can check here, OES you can remove, because this is the torque which is less than load torque. So this is wrong. OFS, so OFS means load torque equals to electromagnetic torque, that is also wrong. Then OPS, therefore it is having torque greater than load torque, it satisfies. And OQRS, so OQRS, this region also having the torque greater than this load torque. But if you see OQRS path, so at this condition, at this speed, this is electromagnetic torque and this is the load torque. So this electromagnetic torque greater than load torque here. So as it is greater, it won't stop at this speed, or it won't rotate at this speed, further it will accelerate. So this path is not correct. So only possibility is now OPS here. That's why option C is correct for this. Next question. This is also from induction motor, and given here some data. Particularly in this question we have stator impedance. Generally for most of the questions we may have stator impedance negligible, then question is very easy. But here stator impedance is there, even R1 0, no? But there is some X1 here, X1 is there, stator reactance is there. So when there is stator impedance, what is the condition or what is the value of slip at maximum torque. So that is little different. But most of the people know what is the slip at maximum torque is Sm equal to R2 by X2. That formula is valid when there is no stator impedance, but stator impedance is there here. So what is the formula when there is stator impedance is Sm equal to R2 dash divided by root of R1 plus X1 R1 square plus X1 plus X2 whole square, X2 dash, X1 plus X2 dash whole square. So here R1 given 0, resistance of stator winding is 0, so you can take 0 it is, then square root cancel. Finally Sm we will get at 50 Hertz frequency it is operating initially, and V by F control it is under. It is driving with a V by F control drive, V by F drive it is. The question here finally, for maximum starting torque, what is the voltage and frequency from drive point of view? So we need maximum starting torque, so that how much voltage and frequency we have to apply. That is the question. First initially at 50 Hertz, according to data, if you calculate, let Sm1 it is, R2 dash, what is R2 dash? 1 ohm divided by R1 is 0, then directly X1 plus X2, X1 plus X2 dash. X1, X2 dash both are same, that is 2 plus 2, 4 ohms, 4 it is total. Then this value is 1 by 4 it is. This is the slip at 50 Hertz. But we need maximum target starting condition. So first of all, for maximum torque or under maximum torque condition, we have one relation of maximum slip is slip inversely proportional to frequency always. At in observations you will get this. At maximum torque, the slip of motor is inversely proportional to frequency. Now according to this we can write Sm2 divided by Sm1 equal to F1 divided by F2 it is, inversely proportional to frequency. So what is the new slip? Because we need maximum torque at starting. At starting maximum torque required. What is the condition for maximum torque? Sm equal to maximum, corresponding slip should be equal to 1, slip at maximum torque should be equal to 1. So this is second case, Sm2 must be equal to 1, already Sm1 we got, how much slip we got already? 1 by 4, this is equal to, F1 is already 50 Hertz, but F2 we need to calculate. So simplify this, you will get F2 equal to 12.5 Hertz it is, F2 is 12.5, and if you see the from options also, with 12.5 Hertz we have only one option, again you no need to find voltage. If you want to find voltage also there is no much calculation required. V by F constant case. So V11 by F1 equal to V12 by F2. So V by F ratio must be constant, apply that, you will get 100 volt 12.5 Hertz it is. Okay. Next. This is from DC machine. So which is our regular model of problem it is. Like load torque, so they will give load torque with different variations, proportional to speed, proportional to square of the speed, or cubic of the speed. So here we have cubic of the speed condition, load torque proportional to cubic of the speed. Read the question first. A DC series motor drawing 40 amps from 400 volt source to drive a load torque proportional to cube of the speed. Load torque is proportional to cubic of the speed, and it has a negligible resistance, resistance not given. Generally Ra plus Rse, that is 0. Find the external resistance required in the armature to reduce speed to half, to reduce the speed of motor by half is there here. Okay, take it is. So speed we have to reduce by half. Initially whatever the speed it is rotating, let initially it is rotating at n, then we have to reduce the speed to half it is. For that how much resistance we need to add in series with armature. So armature resistance control method. What is the procedure? First, calculate initially what is the back EMF of motor. 400 minus IA is there 40 given, IA1. So IA1 is initially 40 amperes. IA1 equal to, it is drawing 40 amps. Let at that time motor is rotating at N1 equal to N it is, motor speed. Now condition is load torque proportional to cubic of the speed. Load torque proportional to cubic of the speed, and electromagnetic torque of series motor we know proportional to square of armature current. So under steady state condition these two are equal always. Now we have to reduce the speed to half. For that first we have to find what is the new armature current by using this torque condition. So let us equate both. Ia square proportional to n cube. From this IA2 by IA1 whole square equals to N2 by N1 whole cube. So simplify from this, IA1 is there 40, N2 is there N by 2, N1 is there N, substitute all the values. We get the new armature current here is 10 root 2, which is 14.14 amps we are getting. Okay, this is our new armature current. First, initially IA1 resistance given 0, that's why it is 400 only, and the new back EMF is EB2 equal to 400 minus 14.14 new current into resistance not given 0 plus some resistance we have to add now in order to reduce the speed by 50%. This is EB2. Then the standard relation N2 upon N1 equals to EB2 by EB1 into phi 1 by phi 2. Now substitute here, this is a half, EB2 is 400 minus 14.14 into RE, external resistance we need to calculate, this is 400, phi 1, flux always proportional to armature current in series motor, which is 40 amps, phi 2 is nothing but 14.14. Simplify this, the value of RE we are getting 23.28 ohms. So this much resistance we have to add in order to reduce the speed by 50% or half. Next question. So 23.28, option B correct for this. Next one is this. This is from transformer. Here given IA plus IB plus IC equal to 0 means balanced 3 phase currents these are. Secondary side we have IA, IB, IC, balanced 3 phase currents. Okay. Then we need what is the relation between IA and IAD. What is IA here? Primary line current. IAD means secondary line current, and what is the angle between these two? There is some relation here, IA by IAD relation. IA is this one, IAD is the secondary line current. What is the line current relation first? So we know very well in 3-phase transformer, phase current ratio is always equals to turns ratio. How? Phase currents I1 by I2 equal to N2 by N1. No? I1 by I2 equal to phase currents, it is equals to N2 by N1 it is. Now according to this, what is the primary phase current here? Primary is star connection here. Primary phase current is same as line, that is IA, divided by secondary phase current. This is secondary phase current, small IA. This is equals to N2 by N1. What is the turns ratio given? 2:1. So N2 by N1 is 1 by 2 here. This is 1 by 2. Therefore, small IA we will get 2 IA it is. Small IA is equal to 2 IA, 2 capital IA. This is phase current ratio. But what we need here, according to question, capital IA by IAD is there. Now, what is capital IA by IAD? Capital IA by IAD. So therefore, this is phase current, small IA. Now see this one. This is line current IAD. What is the line current formula? √3 times of phase current. Therefore, line current small IAD equal to √3 times of phase, that is small IA. This is equal to √3 into 2 into capital IA. Then 2 √3 we get. Therefore, capital IA by IAD equal to what we get? 1 by 2 √3. So this is IA by IAD. Primary line current to secondary line current ratio. IA by IAD 1 by 2 √3. Now there are two options with 1 by 2 √3. 3 options are there here. 3 options. Now we have to find angle also for this. So how to find this angle? Very simple. Phase currents will be in phase on primary and secondary phase currents. Let capital IA, IB, IC. IA, IB, IC. Let us follow any one sequence. IA, IB, IC. So they given negative sequence. Take IA, IB, IC here. And here this is small IA, IB, IC. Secondary currents will be in phase with this small IA. This is small IA. IB exactly in phase with this IC. IB, IC. But we need the relation between IAD and capital IA. IAD means secondary line current. You see this here. According to KCL, this is IA is coming towards this point, and here IC is going outside this node, and this is also going outside. So incoming current is IA equal to outgoing currents IC plus IAD. Now what is IAD from here? IAD equal to small IA minus IC. This is IAD equal to. Now IA minus IC, this is IA, minus IC will be this, minus IC, then the resultant will be this one. This is IAD it is. Then this small ia, this capital IA in phase. So IA also here only. Now what is angle? IAD lags capital IA by 30 degrees here. IAD lags capital IA by 30. So IAD lags capital IA by 30. Option A will satisfy. So these are the questions from machines.
So, hello my dear, let us now discuss the questions from the subject of power electronics. Total 5 questions they asked. So, this is the first question. In the circuit with ideal devices, the power MOSFET is operated with a duty cycle 0.4. In the switching cycle with I equal to 10 ampere, this current value given 10 ampere and V equal to 15 volt, right? This side voltage is 15 volt. The power delivered by the current source in watt. So how much power this current source is delivering? That is what they are asking. So for that, let me consider here first voltage as a Vs. This voltage I am considering it as a Vs. That is a voltage across the current source is a Vs. Now if I find the Vs, I can get the power delivered. What is the power delivered? Power delivered by the current source is simply Vs average into I average, but current I is a constant, so its average value will be only I, right? So I can write simply Vs average into I. So ultimately I need to find here Vs average. How to find Vs average here? So first, this is a MOSFET, we are operating as a switch, alright? So during t equal to 0 to dt, during t equal to 0 to dt, t equal to 0 to dt means t equal to t on, right? Your MOSFET is in on state. Power MOSFET will be in a on state. So tell me, if power MOSFET is in on state means this is acting as a short circuit, na? So current will flow in this loop, right? So what is the voltage Vs? MOSFET on means this is acting as a short circuit. So Vs is equal to 0. So I can write here Vs equal to 0, right? Next, during t equal to dt to t, during t equal to dt to t, during dt to t, MOSFET will be in off state. Power MOSFET will be in a off state, right? So MOSFET off means this is acting as an open circuit, na? So how the current will flow? I, diode and your voltage V, na? Right? So tell me, when this is in off state, can I say that this diode will be in on state? Yes, diode will be in a on state. So when diode on, what is the Vs? Can I say that Vs is equal to V only, right? Vs equal to V, which is equal to 15 volt they have given. So here, during on time of a MOSFET, during off time of a MOSFET, we have written the Vs value. So how will be my Vs? How will be my Vs plot? The Vs plot will be like this: 0 to dt, dt to t. During 0 to dt, Vs is a 0, and during dt to t, Vs is a 15 volt. That is V, 15 volt. Now for this, can we find Vs average? Yes, area upon periodicity.
right? So you can find here 15 into t minus dt upon periodicity is t. So you can get Vs average equal to, from this I can write Vs average equal to 1 minus d into 15 volt, right? 1 minus d into 15 volt, right, into 15. So simply here put the value of duty cycle as 0.4. So 1 minus 0.4 into 15, that is 0.6 into 15, means it is a 9 volt. Now Vs average is 9 volt. So what is the power delivered? So I can write a power delivered is equal to Vs average into I. Vs average into I is nothing but 9 into 10, right? 9 into 10 is a 90 watt na. So your answer will be 90 watt, right? So here answer will be the 90 watt. So power delivered will be equal to 90 watt, right? So this is the answer for the first question. And next question, the three-phase modulating waveforms Va of t, Vb of t and Vc of t used in a sinusoidal PWM. So here sinusoidal PWM in a three-phase they are saying, right? In a voltage source inverter, Va of t, these are modulating voltages, Va of t, Vb of t and Vc of t. Now in a sinusoidal PWM, your modulating voltage is nothing but reference voltage, right? So here reference voltage they have given three phase na, so that's why three reference voltages, right? And they are mutually phase displaced by 120 degree. Now can I say that this 0.8 is nothing but a amplitude of a modulating voltage, means amplitude of a reference voltage. So can I say that amplitude of reference voltage means AR is a 0.8. right, 0.8. Next, where omega given 2 pi into 40 radian per second, fundamental frequency. The modulating waveforms are compared with a 10 kilohertz triangular carrier. So my carrier signal is now triangular signal. Next, which is varying between +1 and -1. So what is the amplitude of a carrier signal given? It is varying between +1 and -1. So amplitude will be equal to +1, right? Next, the VSI has a DC link voltage, that is Vs, input voltage DC voltage, that is a 600 volt, right? And feeds a star connected motor. The per phase fundamental RMS motor voltage for sinusoidal PWM used for a three phase inverter, what is the RMS value of fundamental phase voltage? So here they are asking VPH1 RMS. What is the expression of VPH1 RMS during our classroom session? So written, yes, it is a MA into Vs by 2. This is the peak value divided by √2. So MA is AR by AC. So I can write here AR by AC into Vs by 2, that is 600 by 2 means 300 upon √2. So it is equal to AR is 0.8 upon 1 into 300 upon √2, right? So it is a 240 upon √2. So it will be, you can simplify this, we will get it as 169.71 volt, right? 169.71. So option D is the correct option, right? Yeah, next question. A steady state capacitor current of a conventional DC to DC buck converter. Yeah, capacitor current given for a buck converter, means this is IC given, IC waveform. Next, working in a continuous conduction mode, CCM means continuous conduction mode, is shown in the figure, one switching cycle, correct. If the input voltage is 30 volt, Vs given 30 volt, the value of the inductor used in millihenry is, they are asking what is the value of inductor. So our task is to find the L value. right? Yeah. So there is some typo error in this plot. Actually here it should be minus 0.1 ampere. Yes. Capacitor current is changing between minus 0.1 to plus 0.1 ampere. Here it is given that 15 microsecond, time is in microsecond, right? Tell me if this is 15 microsecond, can I say that this time, check, this current is varying from minus 0.1 to plus 0.1. So minus 0.1 to 0, if it is taking time of 15 microsecond, this is linear plot. Then from 0 to plus 0.1, again it will take 15 micro. So if this is 15, this is 15, this will be 30 micro. This will be your 30 micro, right? Next, if you recall, for buck converter, your capacitor current plot during our classroom sessions we have shown. Yes, this time is your T on, this is your total time T. So I can say that this is T on and this is T off, right? T on and T off. So can I say that my total time T is 50 microsecond? It is given that here T equal to 50 microsecond. T on is 30 microsecond. 30 microsecond, right? And what is the delta IC here? Change in a capacitor current. Delta IC equal to, it is changing from minus 0.1 to plus 0.1 na? So it is a 0.1 minus of minus 0.1, that is equal to 0.2 ampere. So my delta IC is a 0.2 ampere, right? But for buck converter, my delta IC and delta IL both are same. Check our capacitor current plot for buck converter. It is changing from minus delta L by 2 to plus delta L by 2. So my delta IC and delta IL both are same, right? Now here simply write delta IL is equal to D into 1 minus D into Vs into T by L. In that delta IL is 0.2. So in order to simplify this, we need the duty cycle D value first. So what is duty cycle? Duty cycle D equal to T on by T. T on is a 30 micro and total time T is a 50 micro. So it is 3 by 5, right? So it is a 0.6, right? Duty cycle is 0.6. Now put the duty cycle value here. Delta IL is 0.2 I have written, T given, so we can find the L value, okay? So now put here delta IL is equal to 0.2 is equal to 0.6 into 1 minus 0.6 into Vs, Vs is a 30 volt into T, T is a 50 micro upon L, right? D1 minus D Vs into T by L. Simplify this, you will get a L value. It is 1.8 millihenry you will get, right? 1.8 millihenry, right? 1.85 somewhere, okay? Right. So in millihenry they are asking. Next, yeah, in the following circuit, the average voltage V0, that is V0 average given 400 into 1 plus cos alpha by 3, where alpha is the firing angle. If the power dissipated in the resistor is 64 watt, then the closest value of alpha in degree is. So they are asking what is the value of alpha, right? Now here the load is RLE. So as we know, if the load is RL or RLE, in our syllabus we are having only highly inductive na. So simply consider here my load is highly inductive means load current is a constant. Load current is a constant, right? Now here V0 average expression they have given. So first thing is power dissipated in the resistor of 1 ohm, it is 64, right? So power dissipated in a resistor, power dissipated in a resistor R is equal to I0 square into R. Actually it is I0 RMS square into R, but load current is constant, so I0 RMS is nothing but capital I0. So it is 64 equal to I0 square into R. R is a 1. So simplify this, you will get I0 equal to 8 ampere. So my load current is now 8 ampere. right? Further, can I write V0 average equal to, from this branch, I can write V0 average equal to I0 into R plus E. So it is equal to 8 into 1 plus E is 500. So it is 508, right? V0 average is 508 volt. Now use that expression. V0 average equal to 400 into 1 plus cos alpha by 3, right? So it is 508 is equal to 400 into 1 plus cos alpha by 3. Simplify this, you will get value of alpha. Yes, it is equal to 35.9 degree, right? 35.9 degree. Next. Yeah, an ideal sinusoidal voltage source V of t. So supply voltage is sinusoidal 230 root 2 sine of 2 pi into 50 volt. Ideal inductor L through an ideal SCR with a firing angle alpha 0 degree. So now here the load is purely inductive. It is simple single phase half wave control rectifier with purely inductive load. But now they are talking about alpha is 0 degree. Alpha 0 degree means, can I say that my SCR rectifier will behave like a diode rectifier? So it is single phase diode rectifier. Your circuit will behave like a diode rectifier because firing angle alpha is now 0 degree, right? Now here, then the peak of the inductor current, that is peak value of inductor current. Let me write that current as I0. So they are asking what is I0 peak. Recall single phase half wave diode rectifier with a purely inductive load. We have written the expression of I0 peak. Yes, 2 Vm upon omega L. So it is equal to 2 into Vm is a 230 root 2 upon omega, that is 2 into pi into 50 into L. L is 100 millihenry. 100 milli means 0.1 henry, right? Simplify this, you will get I0 peak. Yeah, after simplification you will get it as 20.71 ampere, right? So correct answer is option C. All right. Yeah. So friend, these are the questions from the subject of power electronics, right?
Okay, hello students, coming to mathematics questions. Okay, we have received 4 questions here, generally on memory based. According to the students' memory, these are the questions in mathematics. AB given here, system of linear equations AX is equal to B has 4 options given. Generally, take the augmented matrix here, AB, that is 1, 1, 1. Minus 1, minus 1, minus 1, next 0, 1, minus 1, 0, 1, minus 1, coming to B, that is 1 by 3, minus 1 by 3, 0. Okay, convert the matrix into echelon form, this is A, and if you include last B also, that is AB. Okay, convert the matrix into echelon form. Already in third row, first element is 0. Okay, don't touch this third row. R2 implies R2 plus R1. That is 1, 1, 1, 1 by 3, 0, 0, 0, 0, 0, 1, minus 1, 0. Just you interchange second and third rows. R2 interchange R2 and R3. If you interchange R2 and R3, 1, 1, 1, 1 by 3, 0, 1, minus 1, 0, 0, 0, 0, 0. What is rank of A? Rank of A 2 and rank of AB is also 2. That is less than the number of unknowns. See here, third row is completely 0 row. Rank of A 2, rank of AB is also 2. So both are equal. That is less than the number of unknowns. Number of unknowns means number of columns of A. That is less than rank of A, rank of AB. That is less than 3. So system has infinitely many solutions. Option B is correct. Okay, now coming to the next problem. V1 and V2 are eigenvectors corresponding to the distinct eigenvalues of a 3 by 3 real symmetric matrix. Okay, already this is a direct properties of eigenvectors. Here 3 by 3 real symmetric matrix. For a real symmetric matrix, eigenvectors are pairwise orthogonal. For a real symmetric matrix, 3 by 3 real symmetric matrix means how many eigenvectors? 3 eigenvectors. 2 eigenvectors given. Eigenvectors of a real symmetric matrix are pairwise orthogonal. Pairwise orthogonal means yes. Product of V1 transpose into V2 is equal to 0. Orthogonal vectors, these two. So orthogonal means V1 transpose into V2 is equal to 0. Okay, only option A is correct here directly. Now coming to the next problem, this is a small print mistake. This is IZ. This is IZ. Integral C. Actual question is integral C IZ dz, where C is unit circle. Unit circle means what it is? Center 0, radius 1. Very clear. Function is analytic function. Now, IZ is nothing but analytic function. Okay, analytic function, there is no singular point inside. Clearly that function is in the, see, for the function f of z is equal to IZ, okay, there is no singular point inside this closed curve. If there is no singular point inside the closed curve, okay, by Cauchy's theorem, answer is directly 0. Integral C IZ dz is equal to 0. Since there is no singular point inside the curve. So option, okay, no options, answer is directly 0. Now coming to one more question. Rate of change of V at the origin in the direction of a vector 1 A bar given. Okay, rate of change of V. Rate of change of V means simply what we are asking, that is the directional derivative. Okay, rate of change of V means first I have to find gradient of V. What is gradient of V? Dou V by dou x I bar plus dou V by dou y j bar. Okay, so what is partial derivative of V with respect to x? 2x plus 1. Is it? 2x plus 1 I bar. Is it? 2x plus 1 I bar. Partial derivative of V with respect to y means 2y. That's it. 2y j bar. At the origin, rate of change of V at the origin means divergence of a gradient of V at a point 0, 0. At a point 0, 0 means here 0, only I bar left. Okay. Now, so rate of change of V means directional derivative of V simply. dd of V in the direction of A bar. In the direction of A bar is nothing but what it is? I bar plus 2j bar is del V dot A bar by modulus of A bar. What is del V? Means gradient of V is I bar dot A bar. What is A bar? I bar plus 2j bar by modulus. Modulus is nothing but root over 1 plus 4. Okay. So I bar dot I bar is nothing but 1 or not? So 1 by root 5 is the answer. No options given here. A bar by modulus of A bar means that is 1 by root 5. Clear or not? These are the memory based questions in mathematics. Once if you receive the complete problems, we will publish later. Okay.
Right, students? The next subject is power systems. So in power systems, we got 6 questions of 9 marks, right? So out of these 9 marks, we got more number of questions from power system analysis, and 2 questions from transmission and distribution, and 1 question from the economic load dispatch. That is power system protection and economic load dispatch, right? So see the first question, which belongs to the transmission and distribution. Consider a distribution feeder with R/X ratio of 5. At the receiving end, a 350 kVA load is connected. The maximum voltage drop will occur from sending end to receiving end when the power factor of the load is. They are asking for maximum voltage drop. The maximum voltage drop is nothing but maximum voltage regulation. The maximum voltage regulation always occurs for lagging loads. So we know that the approximate voltage drop, approximate voltage drop in a line is nothing but Vs minus Vr is nothing but IR into Z cos of theta. Actually it is minus R plus phi R, minus for lagging load plus for leading load, as they are asking for maximum voltage drop, maximum voltage regulation, which will occur for lagging loads only. So that we have to take minus phi R. This is the approximate voltage drop. They are asking that this should be maximum. When it will be maximum? This will be maximum whenever this will be equivalent to 1. Whenever cos of theta minus phi R is equivalent to 1, the voltage drop will be maximum. Therefore, cos of theta minus phi R must be equivalent to 1. Therefore, theta minus phi R is equivalent to 0. Therefore, phi R is equivalent to theta is the condition for maximum voltage regulation. Already you have studied. So those who have remembered the formula, directly you can go with this one, right? So the condition for maximum voltage regulation is nothing but power factor angle is nothing but the impedance angle. So what is this one? Theta is equivalent to tan inverse of x by r, right? So they have given r by x value. R by x is 5, where x by r is equivalent to 1 by 5. It is tan inverse of 1 by 5. So if you take tan inverse of 1 by 5 value, you will get approximately 11.31 degrees, and they are asking power factor cos phi r, where cos of 11.31 is approximately 0.981 lag. So 0.981 lag is the answer, right? Very straight away question. Just we need to get at that particular point what they are asking. So very simple, one of the previous question. Right, students? This is one of the best question we can say, actually. So related to the UPS. So those who know somewhat clarity about UPS, they can classify this one. Or otherwise, those who have listened the classes very clearly, so automatically you can answer. During a power failure, a domestic household uninterruptible power supply, UPS, supplies AC power to limited number of lights and fans in various rooms. As per a Newton-Raphson load flow formulation, the UPS would be represented as A. Actually, whenever there is no power outage, UPS is always used to control the voltage. Therefore, under no power outage condition, UPS is a voltage controlled bus. That's why it is a PV bus. But whenever there is a power outage, whenever there is no power, the only source available is the UPS. So the UPS is supplying power to the load. Got it, right? So whatever the requirement of the load, which will be supplied by the source. So we know that the only source, whatever it is available in the power system network, that should be slack bus. We always has to construct a power system with slack bus. We never construct a power system without slack buses. But we can construct a power system without PV buses also. But always there should be at least one slack bus. Therefore, when there is power outage, the only source which is available, that should be a slack bus, right? So what should be the answer? So it should be the slack bus. Got it, right, students? The only source which should be available under power outage condition, it should be the slack bus, right? Again, one of the easiest question. The bus impedance matrix of a 3-bus system is given. This is the bus impedance matrix. The symmetrical fault through a fault impedance also given ZF occurs at bus 2. Neglecting the pre-fault loading condition, the voltage at bus 1 during fault at bus 2 will be. So whenever fault occurs at bus 2, the fault current is nothing but the pre-fault voltage divided by the fault impedance, which is Z22, plus extra fault impedance is ZF. The pre-fault voltage is 1, where Z22, what is the value of Z22? J 0.093 plus fault impedance is J 0.007. 007, it will be J1 by J 0.1. So it is minus J10 per unit. That is the fault current. And they are asking the voltage at bus 1. So where the bus 1 voltage at fault condition is nothing but the bus 1 voltage at pre-fault condition minus the fault current into ZF. That is ZF is nothing but Z12, the impedance between the two buses. So this will be 1.0 minus fault current is minus J10 into what is the value of Z12? J 0.061. J 0.061. If you calculate this one, it is 1 minus 0.61. It will be 0.39 per unit. 0.39 per unit is the answer. Right, students? From economic load dispatch. So this is from the economic load dispatch. Again, the one of the simplest question. It is similar to that of the question asked in the GATE 2024. So once you are able to write the line equation, automatically you are going to get the solutions. 2 units rated at 100 megawatt and 150 megawatt enabled for economic load dispatch, when the overall incremental cost is 10,000 rupees per megawatt hour. The units are pre-dispatched to 50 megawatt and 80 megawatt respectively. At an overall incremental cost of 10,600 rupees per megawatt hour, the power output of the each unit is 80 megawatt and 92 megawatt respectively. The total plant megawatt output at an overall load of 11,800. See, actually, if you are able to draw the line equation, this is power P1, this is the incremental fuel cost of the plant 1. So we can draw a line here. So this is the line we can draw. Initially, we are having 10,000 megawatt, 10,000 rupees per megawatt was the incremental fuel cost. For that one, what is the megawatt power output? 50. For 10,000 it will be 50. And one more incremental fuel cost given, it is 10,600. And for this one, what is the power output it is given? 80 megawatt. 80 megawatt. And one more they are asking 11,800. It will be 11,800. For 11,800, what is the power P1 you have to calculate. Right, students? So first of all, write the line equation for this one. What is that? Y2 minus Y1. Y minus Y1 is equivalent to Y2 minus Y1 divided by X minus X1. That is the line equation we can write. So Y is nothing but incremental fuel cost of plant 1 minus Y1, it is 10,000 is equivalent to Y2 minus Y1, 10,600 minus 10,000, it will be 600 divided by X minus X1, 80 minus 50, it will be 30 into X minus X1, X is nothing but P1 minus X1 is 50. So it is IF1 minus 10,000, it will be 20. It is 20 into P1 minus 50. This is the equation we got. Now, whenever incremental fuel cost is 11,800, if this is 11,800, 11,800 minus 10,000 is equivalent to 20 into P1 minus 50. Right? So it will be 1800 divided by 20 is equivalent to P1 minus 50. It will be 90 is equivalent to P1 minus 50, where P1 is equivalent to 140. But what is the value of P1? P1 you have to maintain is only 100 megawatt. Without overloading any plant, the value of P1 should be 100 megawatt. So that don't take 140, you have to take it as 100 megawatt only. 100 megawatt only. Similarly, draw a line for plant 2. For plant 2, if you draw the line, this is for plant 2. Initially 10,000 rupees per megawatt hour. For that one, you are having 80 megawatt. For 10,600, you are having 92 megawatt. 10,600. For 11,800, what it should be? For 11,800, what it should be? right? So if you do this calculation again, so it is IF2 minus 10,000 is equivalent to 600 divided by 12 into P2 minus 10,000, P2 minus 80, P2 minus 80. So if you calculate this P2 value will get 116 megawatt. So the overall load P1 plus P2 is equivalent to 100 plus 116, it will be 216 megawatt is the answer. Right? So very simplest question. If you are able to write the line equation, that will be very easy. Right, students? So again, the question from transmission and distribution. Right? So very, very simplest question asked for many times. Only thing is here they are asking the line current. Using shunt capacitors, the power factor of a 3-phase 4 kilovolts induction motor drawing a power of 390 kVA at initial power factor of 0.77 lag should be improved to 0.85. So initial power factor is 0.77, it should be improved to 0.85. And what is the line current of the capacitor? So actually here we are having the 3-phase source, and here we are having the 3-phase load. Initially it is operating at 0.77 lag, which is taking a power of 390 kVA. 390 kVA. So here we are having the 3 phases, A phase, B phase and C phase. Here we are having the capacitor bank. And we don't know which connection it is, right? So they have given the 3 connections for this one. This is the 3-phase connection for the capacitor bank. Now we can calculate the capacitor reactive power supplied by the capacitor QC is equivalent to P into tan phi 1 minus tan phi 2, where P is equivalent to S into cos phi 1 into tan phi 1 minus tan phi 2. So where cos phi 1 is given 0.77, S is 390 kVA. It is 390 into 0.77 into tan of cos inverse of 0.77. So tan of cos inverse of 0.77, if you see that value, you are going to get 0.829, and tan phi 2 it is 0.619. So and this value QC you are going to get 63.063 kVAR. That is the value of Q. Once you got the value of Q is equivalent to, actually in the classroom discussion we have done in the phase, QC per phase is equivalent to V phase, I phase sin phi. But here they are asking about line. We don't know about the connection, directly we can take QC is equivalent to root 3 times of VLIL sin phi. But sin phi is equivalent to 1 for pure capacitor, as you have connected pure capacitor. Therefore, IL is equivalent to QC divided by root 3 times of V line. It is 63.063 kilo 10 power 3 divided by root 3 into the line voltage they have given, it is 4 kilovolts. 4 into 10 power 3. So if you calculate this value, the line current that you are going to get, it is 9.1 amperes. That is the line current you are going to get. Right, students? And the last question we can see, in the system shown below, the governor was initially supplying power to the grid. So this is the, not governor, generator is supplying power to the grid. So single emission connected to infinite bus bar system through double circuit line. A temporary triple LG fault, bolted fault, occurs at point F, very close to the circuit breaker 1. The circuit breakers open to isolate the line. The fault is self-clearing. The circuit breakers are reclosing and restoring the total system, right? So automatically circuit breakers are closing and original system will be restored. Which of the following diagrams is best indicating the accelerating and decelerating areas? These are the approximate diagrams they have given, right? So from these approximate diagrams we have to give the answer. So if you see, initially this is the load angle delta, this is the power P, electrical power, and the mechanical power input that you are going to give, this is the shaft power input. For this shaft power input, the electrical power output we are going to get initially is this one. This is the PE1 curve. PE1 curve. What is the initial stable operating point? This is the initial stable operating point. once the fault occurs close to the bus bar, so we can say the fault, the power transferred during the fault will be 0. Therefore, the operating point will be shifted from point A to point B. So if this is point A, this will be point B. And the operating point will follow this 0 power line, and once you are able to clear this one, as fault is on the line, so we are going to draw one more line here, one more wave, which is nothing but P3 curve. This is P3 curve. So as fault is cleared at point C, the operating point will be shifted to point D on P3 curve, and it has to follow this one. But what they are saying, so the fault is cleared here, but after some time, the original network has been restored, so that it may be shifted from here to here, right? So it may be immediately shifted, or maybe taking some time, no problem, right? So what are the areas? This is the accelerating area A1, right? And it will be getting the point here, that is the omega is equivalent to omega s condition at point E. So this is the decelerating area. A2. Right? So this is area A1 and this is area A2. So you can see the options here. So this is area A1 and this will be area A2. This is also looking like that only. So we don't have that much clarity about this question, right? See about the options. So from the given options given by the students, so this is the approximate option we can give for this one. Right, students? So these are the questions we are having from the power system point of view, right?
Okay, my dear friends, last but not least, from the general apti, we received only 2 questions. Two questions only. One is simplification. 3 power 81 upon 27 power 4 whole power 1 by 3. Simplify the equation. This is 1 mark question only. So 3 power 81. So here 27 written as in terms of the base 3. So 27, 3 power cube. So 3 4s are 12. 3 power 81 upon 3 power 12. Okay. Whole power 1 by 3. So you can observe 3 power 81 minus 12 whole power 1 by 3. Okay, whole power 1 by 3. You can simplify 3 power 23 is the answer finally. But 1 more question, my dear friends. Okay, next. Another question from the reasoning. Just very easy logic. Number of times we discussed in the classroom also. Okay, some of the students know, and remaining students also very easy. Okay, E 5 6 F is 6 5 6 0 30 6 7, 42 important, H 8, J 10. So 80 is the answer. Okay, product of the latter numbers is the logic. So it depends upon the given options. We have to select the same logic, my dear friends. Okay, these two questions exactly we are getting the information from the students. Remaining not exactly. That's the reason we not discussed these two only. Okay, friends. From the students, we are getting this type of information, only memory based purely, okay, not exactly, pure memory based, 99% it will be right. Okay, friends, all of you, thank you, all the best.